Close your eyes for a moment. Imagine a world where gravity, the force that anchors us to the ground, weakens its grip. Picture yourself taking a leap, only to find yourself floating higher than ever before. This is the intriguing scenario we're about to explore, a world where the very fabric of our existence, gravity, is subtly altered. We often take gravity for granted, this invisible force that dictates so much of our lives. It keeps our feet planted firmly on the ground, determines the arc of a thrown ball, and even governs the motion of planets in our solar system. But what if this fundamental force were to change? What if Earth's gravity decreased, even by a small percentage? The consequences, as we'll soon discover, would be nothing short of extraordinary. From the way we move to the very air we breathe, the effects of reduced gravity would ripple through every aspect of our world. Join me as we embark on a journey to uncover the mind-boggling implications of a world where gravity takes a break, a world where the impossible becomes possible. Before we delve into the hypothetical, let's take a moment to appreciate the profound influence of gravity in our lives. Gravity, in its simplest form, is the force of attraction between any two objects with mass. The more massive an object, the stronger its gravitational pull. Think of Earth as a giant magnet pulling everything towards its center. This is why objects fall to the ground when dropped. It's also why we have weight, which is simply the force of gravity acting on our body's mass. This invisible force isn't just limited to Earth. Gravity holds our moon in orbit, guides the planets around the sun, and even influences the interactions of galaxies across the vast expanse of space. It is the architect of the cosmos, shaping the universe as we know it. Albert Einstein, in his groundbreaking theory of general relativity, revolutionized our understanding of gravity. He proposed that gravity is not merely a force but a curvature in the fabric of space-time, caused by the presence of mass and energy. Imagine a bowling ball placed on a trampoline. The ball creates a dip in the trampoline's surface. Now if you roll a marble across the trampoline, its path will curve as it passes near the bowling ball. This curvature, according to Einstein, is analogous to how gravity works in the universe. Now let's step into the realm of what-ifs. For the sake of our exploration, let's imagine that Earth's gravity decreases by a significant but not catastrophic amount, say, 10%. This decrease, while seemingly small, would have profound and far-reaching consequences for our planet and everything on it. We can envision this decrease happening in one of two ways: suddenly, like flipping a cosmic switch, or gradually, over a more extended period. Both scenarios present unique challenges and opportunities for life on Earth. A sudden decrease in gravity would be immediately noticeable. We would feel lighter on our feet, objects would fall more slowly, and our gait would become somewhat bouncy. Imagine the chaos as athletes shatter world records, and everyday activities like walking and climbing stairs become a test of balance and coordination. A gradual decrease, on the other hand, might be less perceptible at first. However, over time, the cumulative effects would become increasingly apparent, leading to subtle yet significant changes in our physiology, our environment, and even our planet's place in the cosmos. Whether sudden or gradual, a 10% decrease in Earth's gravity is a thought experiment with the potential to upend our understanding of the world as we know it. One of the most immediate and obvious effects of reduced gravity would be on our physical movements. Imagine stepping onto a scale and finding that you weigh 10% less than usual. This newfound lightness would undoubtedly feel liberating at first. We could jump higher, run faster, and lift heavier objects with greater ease. However, our bodies, finely tuned over millennia to Earth's current gravity, would likely face challenges in adapting to this new environment. Our balance and coordination, so reliant on the inner ear's vestibular system, would be thrown off kilter. Simple tasks like walking in a straight line or catching a ball could become surprisingly difficult. The inner ear, responsible for our sense of balance, relies on tiny calcium carbonate crystals that move in fluid-filled canals in response to gravity. A sudden change in gravity could disrupt this delicate mechanism, leading to dizziness, disorientation, and even nausea. Over time, our bodies would likely adapt to this new normal, recalibrating our internal gyroscopes and regaining our sense of balance. However, the initial period of adjustment would undoubtedly be a time of awkward stumbles and unexpected tumbles. The long-term effects of reduced gravity on the human body are perhaps even more intriguing than the immediate ones. With less gravitational force compressing our spines, we might experience a gradual increase in height over generations. Imagine a world populated by taller, more slender humans, their bodies adapted to a lighter gravitational load. However, this skeletal elongation might come at a cost. Our bones, accustomed to supporting our weight under Earth's current gravity, might become less dense and more susceptible to fractures in a reduced gravity environment. Astronauts who experience prolonged periods of microgravity in space often face bone loss and muscle atrophy upon their return to Earth. Muscles too would undergo adaptations. With less gravity to work against, our muscles might become weaker over time. This could lead to a decline in overall physical strength and endurance, making even everyday activities more challenging. The cardiovascular system, responsible for circulating blood throughout the body, would also need to adjust to the reduced workload. The heart, no longer required to pump blood against the same gravitational force, might become less efficient, potentially leading to cardiovascular problems in the long run. The human body is remarkably adaptable, capable of adjusting to a wide range of environmental conditions. However, the long-term consequences of reduced gravity on human physiology are complex and multifaceted, warranting further exploration and study. Our atmosphere, a delicate shroud of gases that envelops our planet, is held in place by Earth's gravity. A decrease in gravity would weaken this hold, potentially leading to a gradual thinning of our atmosphere as gases, particularly lighter ones like hydrogen and helium, escape into the vastness of space. This atmospheric escape would have profound implications for life on Earth. Our atmosphere acts as a protective shield, absorbing harmful ultraviolet radiation from the sun and regulating our planet's temperature. A thinner atmosphere would mean less protection from the sun's harmful rays and a greater susceptibility to temperature extremes. Furthermore, a thinner atmosphere would affect our weather patterns, potentially leading to weaker winds, altered precipitation patterns, and an overall shift in global climate. The delicate balance of our planet's climate system, so crucial for life as we know it, could be thrown into disarray. The thinning of our atmosphere is a gradual process, but its effects, if left unchecked, could be devastating. It underscores the interconnectedness of our planet's systems and the importance of gravity in maintaining the delicate equilibrium that supports life. The rhythmic ebb and flow of ocean tides are a testament to the gravitational dance between Earth, the Moon, and the Sun. The Moon's gravitational pull is the primary driver of tides, but the Sun also plays a role. A decrease in Earth's gravity would weaken its grip on the oceans, leading to less dramatic tidal ranges. High tides might not be as high and low tides might not be as low. This shift could disrupt coastal ecosystems and marine life. Ocean currents, driven by wind, salinity, and temperature, are also influenced by gravity. A change in gravity could alter these currents, affecting marine ecosystems and global weather patterns. A weaker gravitational pull could lead to increased evaporation rates. Water molecules would be more likely to escape into the atmosphere as water vapor. This could change precipitation patterns, impacting agriculture and climate. The oceans, covering over 70% of Earth's surface, play a vital role in regulating our planet's climate and supporting life. Any disruption to their balance could have far-reaching consequences for the entire planet. Our planet's position in the solar system, a delicate balance of gravitational forces, is also influenced by Earth's own gravity. A decrease in Earth's gravity would weaken its gravitational pull on the Sun, potentially causing our planet's orbit to widen slightly. This subtle shift in our orbit could have significant implications for Earth's climate. As our planet moves slightly farther from the Sun, the amount of solar radiation reaching its surface would decrease, potentially leading to cooler temperatures and shorter growing seasons. The length of a year, determined by the time it takes for Earth to complete one orbit around the Sun, would also be affected. With a wider orbit, a year would become slightly longer, disrupting our calendar and potentially impacting agricultural cycles. The delicate balance of our planet's climate, so reliant on the precise distance from the Sun, could be thrown into disarray by even a slight change in Earth's orbit. This highlights the interconnectedness of our solar system and the profound influence of gravity on a planetary scale. Life on Earth has evolved over billions of years under the influence of gravity. A decrease in gravity could serve as a catalyst for new evolutionary adaptations. Plants might grow taller and more slender, trees could reach for the sky with wider branches, Animals would also adapt. Birds might evolve larger wingspans. Land animals might develop lighter skeletons and efficient muscles. The possibilities for adaptation are vast and varied. A world with reduced gravity could become a hotbed of evolutionary innovation. Life finds a way. This spirit of adaptation has allowed life to flourish for billions of years.